Hello guys, welcome back to our channel at Smart Edu TV. If you are new to this channel, remember to turn on the notification bell and click on the subscription button so that you never miss on an important update. For our old subscribers, thank you for trusting us. Hello viewers, welcome back to our channel. Today, we are going to be discussing introductory statistics. What is statistics? There are different scientists that had contributed to the understanding of the definition of statistics. One of such scientists include Webster. Also, we have Bode. Then we also have Yule and Kendall. Yule and Kendall. So these are some of the scientists that has contributed to the understanding of the definition of statistics. We are going to be looking at these scientists one after the other. Okay? So, according to Webster, he defines statistics as a classified fact representing the conditions of people in a given state. Webster defines statistics as a classified fact that represents the conditions of people in a given state. According to Bode, he defines statistics as a numerical statement of facts in any department of inquiry in relation to each other. And according to Yule and Kendall, they define statistics as a quantitative data affected to a marked extent by multiplication of curves. So these are the definition of statistics according to these authors. Okay, the next we are going to look at is the classification of statistics. How do we classify statistics? Statistics generally can be classified into two. That is, the descriptive statistics and the inferential statistics. What are we trying to say? We can classify statistics into two, the descriptive statistics and the inferential statistics. Descriptive classification of statistics. So the first one we have what? Descriptive. And the second one we have what? Inferential. Okay? For the descriptive statistics, it deals with the summarization and describing of what? Data. It describes and what? Summarized data. But for the inferential statistics, it draws conclusion from a given set of what? Data. It draws what? Conclusion from a given set of data. So that is what the difference between descriptive statistics and inferential statistics. For descriptive, it describes and summarizes, while for inferential statistics, it draws conclusion from a given set of what? Data. The next thing we are going to look at is data collection. In statistics, the first step to any statistical investigation is data collection. How do we collect data? But before we move to data collection, there are some preliminaries to data collection. There are some things that we need to put in place before we collect data. And these include the source of information. We have to know the source of our information. We don't just collect data from anywhere. We have to know the authenticity of that source. The next is the type of inquiry. Every investigation has its own specific inquiry. What are the things we are looking for? What are the things we want to know concerning that investigation? The third one is the method of data collection. There are different methods of what data what collection. Is it what the primary data or is it what secondary data? The next we are going to look at is the targeted degree of accuracy. What is our expectation at the end of the what? The data collection. What is our degree? What is our targeted degree of what? Accuracy. The next we are going to look at is the objective and the scope of the inquiry. What is the aim of embarking on that data what? Collection? Why are we collecting the data? What is our aim? What is our objective? The next, which is the last, is the statistical units to be used. The statistical units to be used. These are preliminary to data what? Collection. So after we understand all these, then we cannot go ahead to collect our what? Data. The next we are going to look at is the characteristics of a good data. What are the features of a good data? Number one, a good data should be what? Unambiguous. It must not be too big. A good data should be what? Unambiguous. Number two, a good data should be specific. It should be what? Specific. Number three, a good data should be what? Stable. It should be what? Stable. Number four, a good data should be what? Uniform. There should be uniformity in that data. A good data should be what? Uniform. And number five, a good data should be appropriate. A good data should be what? Appropriate. These are the characteristics of a good data. It must be uniform, it must be stable, it must be appropriate, it must be unambiguous, and it must be what? Specific. These are the characteristics of a good data. So the next we are going to look at is the method of data collection. The method of data what? Collection. There are two methods of data collection, as we've said earlier. There are two methods of what? Data collection. Method of data collection. As we said earlier, there are two methods of data collection. The first method is called the primary data. Primary data collection, or simply primary what? Data. What are primary data? Primary data are data that are collected by the observer, by the investigator him or herself. The data that is collected by the observer is called what? Primary data. That data has not been collected by that observer before. It is what? Known as primary data. While the second type or the second method of data collection is called the secondary data. Secondary data. What are secondary data? These are data that has been used and reused over time. They are data that have been what? Used and reused over time. Either it can be used by the what? By the observer himself, or maybe by what? By some agencies or organizations. They are data that have been what? Used and reused over time. Those are what? Secondary data. So the next thing we are going to look at after the method of data collection is to look at the frequency table himself. Frequency table, or we call it what? Frequency distribution. Frequency distribution. What do we mean by frequency distribution? So a frequency distribution is simply like what? Like a table that shows the what? Different values or different qualities or observations and how they are spread. It shows different observations and how they are what? How they are spread on the table. That's what we mean by what? Frequency what? Distribution. Is a table that shows what? Different data and their number of frequency. It shows different data and their number of what? Frequency. That is frequency distribution. So the next we are going to look at is the frequency distribution stages. We want to look at the stages of frequency distribution. There are four major stages of frequency distribution. There are four major stages of frequency distribution. The first stage is called the raw or the array data. The second stage is what? Is the continuous data. The third stage is what? Ungrouped data. And the last stage is the what? The grouped data. So these are the what? The stages of frequency distribution. These are the stages of frequency what? Distribution. The raw or the array data, the continuous data, the group data, and the ungrouped data. These are the stages of frequency what? Distribution. So the next thing we are going to look at is the Sturge'S rule. Sturge'S rule. How do we use Sturge'S rule to apply to what? A given set of data. So next heading, we are going to look at Sturge'S rule. Sturge'S rule. Sturge'S rule. So what do we use Sturge'S rule for? We use Sturge'S rule to actually know the class interval. We use Sturge'S rule to know our what? Class interval in a given set of what? Data. And it is given by the formula k equals 1 plus 3.322 log n base 10. 1 plus 3.322 log n, where k is what? The class size or the class what? Interval. Where k is the class size or the class interval, our n is the what? Number of data. How many data are we given? Our n is the what? Number of observations or number of what? Data given. Number of what? Data given. Where our k is what? The class size. Our k is the what? Class size. So let's now see how we use the Sturge'S rule in a given problem. Okay. So if you look at this question, they want us to use what? Sturge'S rule. They've given us some set of data in which we are to form a group frequency distribution from this data by using Sturge'S rule. How do we do this? This is very simple actually. Don't forget, before you can use Sturge'S rule, always remember your formula. That is to find what? The class interval. That is k equals 1 plus 3.322 log to base 10 of what? N. Log to base 10 of what? N. Where this k is what? Is the class interval. I want to know the what? The class what? Interval. So here, my n is the total number of what? Data given to me. If you count this data, you can see each of them are separated by what? By a comma. If you count each of them one after the other, you will notice that everything altogether equals 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 in 3 places, 36. 36 plus 4, making what? 40. It means that what? My n equals what? 40. It means that what? The total number of data given to me is 40. Also, so if I use my what? My calculator to find what? The class interval, it means that what? My k is going to be equal to what? 1 plus 3.322 log 40 base 10 or log 40. 1 plus 3.322 log 40. So if I punch this in my calculator, I'm going to have log 40 multiplied by 3.322, then plus 1 plus 1. I'm going to have 6.32. The value of k in my calculator gives 6.32. So look at here. We've gotten about the class interval to be 6.32. If you look at 6.32 to the nearest whole number is what? 6. Since this is not up to what? 5. To the nearest whole number is what? 6. It means I've gotten the value of k to be what? 6. It means that what? My class interval at the end of the day, after I finish solving, should be what? 6. That is from so class to so class, number 1, another class to another class, number 2, number 3. I'm going to have about 6 different what? Class interval. So let me now see what? How I evaluate this. So after getting the what? The class interval, the next thing for us to determine is the what? Is the width. How do we find the width from this given set of data? Our width, W, is given by the formula range over K. Our width, W, is given by what? Range over what? K. We need to find the width so that we are going to know what? How the what? The width of what? Of that class interval. We are going to use it to know the width of what? Of that class interval. So from this given set of data, our width is given by what? Range over what? K. Where our range is the highest minus what? Lowest in this given set of what? Data. If you check these numbers very well, you will notice that the highest number there. Okay? So to find out, we don't forget range over what? Over K. Where our range equals for the highest set of data minus the lowest set of data. So if you check this data set very well, you will notice that the highest number here is what? Is 38. The highest number here is what? 38. So I'm having 38 minus the lowest given set of data here. The lowest number here is what? 10. The lowest number here is what? 10. So 38 minus 10 divided by the value of k we've given to the nearest whole number is what? 6. 38 minus 10 divided by what? 6. So this will give us, what is 38 minus 10? 38 minus 10 will give us what? 28. So 28 divided by what? 6 to get what? Our width. So our width is going to be equal to 38 minus 10 will give us what? 28 over what? 6. So what is 28 over 6? This will give us 4.67. 4.67. Also, to the nearest whole number, this will give us what? 5. Approximately what? 5 to the nearest what? Whole number. Since this is what? Is bigger than what? 5. So our width is what? Approximately 5 to the nearest whole number. So in choosing our class interval, it means that what? For the class width, the lowest number is what? From 10. The highest number is what? Is 38. So that means the class size is what? Interval of what? 5. Okay, as you can see, our width is now what? 28 over 6, which is approximately equal to what? 5. So it is this 5 that we used to know about our class width. Starting from what? From the lowest number. The lowest number here is what? Is 10. That means from 10 to what? 14. 10, 11, 12, 13, 14. That is what? Size 5. It means that the width should be what? 5. That means from 10 to 14 will give us what? Size 5. So that means what? My final result will now be from 10 to 14, from 15 to 19, from 20 to 24, from 25 to 29, from 30 to 34, also from 35 to 39. And I'm going to stop at that because that is the last one, which is the 61. So I'm going to have them like this. So my final result using Sturge'S rule will now be, so I'll print this. So at the end of the day, this is our final result of the Sturge'S rule. This is our final result of the Sturge'S rule. You can see the class interval and also the corresponding frequency. The class interval and the corresponding frequency.